Started. Hello, everyone. Today we have a really good speaker, which is Sophia. Sophia has been my guest speaker at Stanford, and she's a graduate from Stanford. She's extremely knowledgeable about blockchain. She used to lead at Celo, and she knows everything. So Celo is another blockchain, which is not the focus today, but she did tremendous effort there. And last time I met her, and she told about what they're doing about MiniPace. Now she's moved um, to Ethereum Foundations just recently, and she's going to show us what Ethereum Foundation is going to do with AI. And I, I'm just looking forward to it. And then for logistics, please just put your question in the Q&A sessions. And Sophia, please make some stops because people may have clarification questions, and maybe it's just good to make sure everyone's synced. And the floor is all yours.
Amazing. Super excited to be here. And yeah, just as mentioned before, at any point, if there are any questions, please feel free to add in the Q&A. Would love to make this collaborative and an ability for us to discuss. Let's see, can everyone see my screen okay? Great. Awesome. Cool. And then wait, let me just make sure because I can't see comments right now. And so I just want to make sure I can still see the chat. So if I pull up the chat in a little chat window. Great. Awesome. Well, thank you so much for the introduction. And yes, as a little reminder, I'll just do a quick introduction of myself as well. But yeah, I had the pleasure of being a guest honor in Professor Sue's course and back at Stanford, and I was also a student there myself. So super cool to be all full circle. And additionally, I now am on the developer acceleration team at Ethereum Foundation. And so a lot of my role is talking to builders about what Ethereum is doing. What are the exciting reasons to come build on Ethereum? What are some of the principles, the design principles? What are the examples? What is the actual protocol and embedded on the protocol that gives it context to why Ethereum as well? And so that's a little bit from the context that I'll be speaking about today. And so today I wanted to walk you through Ethereum and specifically what Ethereum is doing in the AI landscape. I'm from San Francisco and I'm based in San Francisco. So a lot of the talks that I'm giving to builders, especially at events and when I'm talking to companies and here, the number one question I get asked is, what is Ethereum doing with AI and for AI? So very excited to give more of a insight into that here. So I'll be starting off this presentation slash panel slash back and forth Q&A. We can take it in whatever direction the audience wants to go, but I'll start off with a big picture of what's happening right now in the intersection of these two technologies. And then I'll explain what Ethereum actually is, show you from the ground up, show you why its specific properties make it uniquely relevant for AI. And then I'll walk you through the actual infrastructure, real projects, real adoption that is already live on the network. So if that sounds great with everyone, I'll just jump on in. Cool. So, over the last few months, it's no secret there's been significant improvements in LLMs, and they have expanded what AI can do. So, from when you think of the first version of the chatbot or ChatGPT, or your first version of like more the consumer adoption side of AI, it's like these smart AI, like autocomplete chatbots. But right now, currently, and we're at the very early stages of it, especially with the latest Opus 4.6, we are at the agents and AI is starting to become a lot closer to an actor in the economy. Today, agents are not just, or AI is not just answering questions, they're actually out there doing things. You're probably experienced having it write and ship code for you. If you've ever experienced with like vibe code tools, you could tell that 6 months ago, these tools were not at the place where they are now. Now there is a really real reality that we have bug-free code in all of the software that we write. That is a reality that we can kind of live in because of the significant improvements in these models over the past few months. Like AI they're doing things, they're coordinating online, they're moving money around, they're making purchasing decisions on your behalf, they're negotiating with other pieces of software. Sometimes they're even hiring other agents to complete subtasks. So this is all happening right now on the existing internet. One of the big popular things are like trading bots. I'm sure if you are well versed all over tech Twitter, you're probably seeing a lot of bots that are like, okay, they did these trades and seeing how they're actually making and transacting online. A lot of bots are paying for their own compute. So how do you stay alive and pay for your own compute and fully coordinating with each other? So this is actively happening currently in today's day. So when you start to see that, we stop thinking of AI as just a tool you can query. We're starting to see it as a new type of economic participant. And when you have a new type of economic participant, the next question is, all right, what rails do they run on? What infrastructure are they using to pay? Um, what Yeah. What what are they using to build trust? What are they choosing to make commitments? And what I'll get into a lot more today is Ethereum and the actual coordination layer for value and commitments for AI. So on one side, we have AI that's become this new type of economic participant. It helps us think. It helps us take action in the economy. And at the same time, we have Ethereum. And if you're familiar, actually, this is a good question. What's the context in the audience? Like, how familiar, what's the background here with Ethereum?
I think people are relatively familiar with Ethereum,
Cool.
and many of them, yeah,
Yes, yes,
study
yes.
Ethereum.
Sitting here, okay, cool. So sometimes I go from first principles when I'm talking to some like developers. So here I'll gloss over first principles, but just go into the actual like protocol, of what's exactly happening. So, Ethereum's infrastructure, it's built for ownership, identity, payments, forcible agreements, and doesn't have a central operator. So Ethereum is perfectly positioned to be this coordination layer for value and commitments. And I'll dive a little bit more into what that actually means and tangibly means from the protocol level in a little bit. So something that's kind of exciting, Davide Kropis, he is the head of DAI at Ethereum. So he leads the decentralized AI initiatives at Ethereum Foundation. And I'll jump into some specific research and protocol research that the team is currently working on. But wanted to share, he posted this article in 2024, so about a year and a half ago, and it was about the Internet of Agents. And this was a research piece that was describing bots transacting with each other autonomously. At the time that he published this article, a lot of people thought it was very futuristic. They're like, okay, like this is interesting, this is cool, the Internet of Agents, but this is not my reality. My reality is I book my reservation through using OpenTable or Resi. I'm not telling an agent and it's not booking it with another agent. That's just not my reality. So this whole research piece on the Internet of Agents just wasn't relevant. He also put this graph out here. So the age of assistance, and then we are right here. So this little red dot. And the point behind it is that then we're going to get into this age of agents and this exponential growth of things happening and doing things on their own and expanding. And so this was interesting to just think about. This is not that long ago that he put out this article, and people were like dismissing the futuristicness of this research piece. And then about less than a year later, ERC 8004 went live. So 8004 is a standard for trustless agents on Ethereum. And that actually went live in this past January, so a few months ago. I'll jump even more into 8004 a little bit later, but as a high level, it has three on-chain registries. You can register an identity, a reputation, and a validation registry. And so it allows agents to actually be discovered, choose, interact which agents across different organizational boundaries it can interact with, even if it doesn't have pre-existing trust. So it really enables open-ended agent economies. And ERC 8004 gives agents a standard way to be registered, discovered, and evaluated on chain. And so the funny thing is the week that Ethereum EIP, sorry, 8004 went live, um, was the same time that OpenClaw went viral on all over everything. So yeah, OpenClaw, in case you're not familiar, but I'm sure you're all familiar, it's this local open source operating system level agent framework. So you can run it on your machine or server. It connects to chat apps like Telegram, WhatsApp, to an agent. The agent can call skills to do real things. It can read, write files, send emails, call APIs, hit internal services, run shell commands. And what we started to see this January, so this is very, very new. We're fully, you remember that graph I shared earlier with the red dot? It's like we're just at the start of that red dot. And that is like the very beginning. So we are starting really to see a proliferation of AI agents who are writing code, moving money, purchasing decisions, negotiating with other agents, hiring other agents, just agents out on the open web. And so there's been a huge increase of them right now. So the big reason, though, that infrastructure matters is these agents right now are interacting on the internet. But the internet, as it is and as it's designed, is designed for humans. It is not designed for agents. So think about these agents, they're transacting, they're negotiating, they're running payments, all of this is happening on infrastructure. And this infrastructure that they're interacting and coordinating on is shaping everything about how the economy on top of it works. So that's one piece to hold on to. But if you think about how a human interacts with the internet, right? We have logins, we have passwords, we have, if someone rugs us, maybe you can go to the court. We have API keys. You have payments that are run through a banking system. Often you're connecting your Stripe and it's connecting, and then you could put your credit card and credit card information. Agreements, if you're trying to make some agreement, maybe it's enforced by a legal system, or maybe sometimes it's enforced by a brand, like where should I book my restaurant reservation between OpenTable and Resi, or North Korea malware reservation.com. Like humans have that trust brand association of like, okay, here are the tools that I can trust where I can put my money into. But agents don't have that same knowledge as well. And so that's one of the piece. The actual infrastructure that agents are running on is not designed for agents themselves. They're designed for humans. Additionally, everything is running through servers that are owned by certain companies. So when you think about the actual infrastructure and how these agents are transacting and who's going to be ruling like the roads of how they're talking to one another, do all payments happen via like one endpoint that's owned by one company? Who actually defines the standards for how all of this infrastructure shapes the economy on top of it? So agents, can't use human infrastructure in the same way humans can use human infrastructure. They just very simply, they can't store passwords correctly, securely. If you give an agent your password, and often if you've used OpenClaw and you've tried to interact and have it do things on your behalf, you are fully giving it your password. And everything that this agent is receiving, any credential you give it, can become a potential vulnerability. And it's not exactly a software patch that software bug you can patch. This is pretty structural to how these language models work. And they can't be on their own opening bank accounts or going through an identity verification process that's designed for humans. There's no KYC process for a piece of software. Can't be like waiting days for payments to settle, and they're operating at machine speed, right? They can't be relying on courts for legal contracts. There's no legal framework for enforcing the agreement between an agent and an agent. If an agent scams another agent and you can't exactly identify like who's responsible, who does that, or you have some escrow contract and there's a dispute, how do they settle that dispute? Does it go then back to the human? How does it happen when you have layers and layers and layers where you maybe have an agent that's controlling many sub-agents? They also just can't build reputation through the channels humans typically use, like referrals, social trust, a professional network. An agent doesn't have fear of consequences. There's no social standing. It can be copied infinitely, so a bad actor could spin up a fresh new identity whenever it wants. What's really happening here that I want to emphasize is we are launching a new class of economic actor. We're seeing a new economic actor that is emerging in the market. And the infrastructure underneath how this economic actor interacts in the world currently isn't designed for what they do and what they can do. So the big question here that we as the Ethereum ecosystem, and especially at the Ethereum Foundation, DAI team, developer acceleration team, that we're trying to determine, $1 million question, is the infrastructure that AI agents transact right now, and the design choices being made will compound as AI activity scales. So the big question is who can participate? What should this infrastructure look like? Who should control it? And what properties does it need to have? And I can't emphasize this enough that right now we're in such early days. You saw the graph of where we think we are as it comes to the future of how agents interact in our day-to-day lives, how agents are interacting in our economy. The choices we make right now have compounding effects on the activity that will scale on top of them and how these things will interact. And so it's really important that we go into first principles design thinking of how do we want to design these protocols? How do we want to design these rails for AI? And what does this actually look like and mean? So before I go any further, I want to anchor in this idea. Ethereum for AI really means Ethereum for humans. The goal with Ethereum and as they're interacting is not necessarily to give AI agents full autonomous independence on their own and being like, hey, here are the rails, go run. Really, it's more to make sure that humans are able to delegate more economic activity to AI and that the infrastructure underneath keeps humans in control of what those agents do and how they operate. So we want to ensure that humans continue to have agency, ownership, and control in the age of AI. And this is the big piece that I want to emphasize again and again, because we talk a lot about Ethereum for AI, all the cool things that AI can now do when it's like sovereign free, allowing, but really what we talk about freedom and sovereignty, that's human freedom and human sovereignty, and ensuring that as AIs become more of an economic participant, we have the guardrails in place to ensure that they're operating in a way that's aligned with human interests. So I'll now show you why Ethereum specifically is positioned to deliver on this. Let's just start from the ground up on what Ethereum actually is. The reason it matters from AI for AI comes from very specific properties of the system. So Ethereum itself, it's a public programmable blockchain, means shared ledger contained by thousands of computers around the world. You can deploy programs. It executes automatically based on rules you define. And since 2015, right, it's been able to handle over, or it currently handles billions of dollars in economic activity. I think we've really seen that with Genius Act, a lot of the latest legislation that's passed. We have over, I think, 65% of any single real world asset that's on chain is on Ethereum. And so we are the home of most real world assets that are on the blockchain in general. And there is billions, billions, and billions of dollars of economic activity that flows through Ethereum's economic rails every single day. And of course, as a blockchain, the entire thing, it's open source. Anyone can read, audit it, build on top of it. No single company who runs it, hosts it, or controls it. I honestly, I work at Ethereum Foundation, but it's not a company, right? It is a foundation. We are stewards of the network. We contribute key research and key initiatives on the network. But at the end of the day, if we were all to disappear, this Ethereum Foundation were to disappear, we're not a company. The Ethereum can continue to stay persistent with or without us. So Ethereum does two fundamental things, and I want to press in on this because this is fundamental to how AI and properties for the AI rails will actually work. First, it lets you own things digitally without an intermediary. When you hold an asset on Ethereum, you're holding it directly with your cryptographic key, right? It's not in the company's database. It's not happening through a platform. The ownership is yours, verifiable by anyone, and no one can revoke it without your key. The second piece is it lets you coordinate with others without a central operator. So you can make agreements, pool resources, trade, vote, organize. And this is all happening via the actual smart contract. These are rules, pre-trusted commitments. These are commitments you can't break because they're written in how the code and what you're actually using and interacting with follows a set of rules. And these rules execute exactly as they are written. Neither party can change the terms after they're deployed. And there's also no third party to enforce them. So I'll gloss a little bit about how it works from the technical mechanics, but yeah, high level, we have this public ledger. Anyone's reading it. Anyone can interact with it. This ledger is replicated across thousands of computers worldwide. Smart contracts, these programs that are actually deployed on the network and actually run exactly as written. And the network that's maintained by validators. And these are participants who stake their own Ether as collateral. One thing I want to emphasize here is the more validators, the more secure the network. And Ethereum Foundation is doing a lot of really cool research. And one of our latest upgrades that we've done makes it super easy for anyone to run a validator. Long-term vision, if you look at our long-term roadmap, validity, we can run it from our phones, very, very easy, very simple. And in that world, the more people are running these validators, the more secure the network continues to be. But what I really want to talk about is the design principles that are embedded into Ethereum's, that are uniquely embedded into Ethereum, because this is the reason that Ethereum is specifically relevant for AI. And this is also the differentiation between blockchain in general. All the things prior to this, we'd say, well, you could do that on another blockchain. You can do that on Solana or another, whatever, on BNB chain. But these are the design principles that make Ethereum unique. And this is why these design principles are relevant for AI and specifically Ethereum. So the key design principles within Ethereum are, I like to use the acronym CROPS. It stands for censorship resistance, open source and free, privacy, and security. So when we think of censorship resistance, this is where no single actor can selectively block a valid transaction or exclude a participant from the network. And it's architectural, right? Thousands of independent validators are processing these transactions. There's no single point where someone can filter activity. And what this actually means in practice means if you deploy a smart contract in Ethereum, it runs. Doesn't matter if someone disagrees with what it does. The protocol relies on cryptographic guarantees, not on anyone's approval. When it comes to open source and free, every piece of the system is public. Anyone can read the code, audit it, copy it, fork it. And this means that if people maybe disagree with the direction Ethereum is going, they can actually audit, understand what is actually happening. And so um, even things that like the foundation, so on our end, we do support many projects and open source projects in the ecosystem, and they do have to make a pledge that they cannot change their open source license. This is a hard requirement. There's some really amazing technology and cutting edge research happening from the privacy team at Ethereum around zero knowledge proofs. And fun fact, my last company that I worked at, Cello, we actually, yeah, like Aqua hired one of these like teams that they bought called Self Protocol, and it's zero knowledge proofs that let you prove your identity from your biometric passport or identification system and use that within like systems like your agent or as you transact online. And all of that code continues, even though now it's a private company, all of that code, all of that knowledge continues to be public and open source. And those are one of the core principles between all of the projects that we support on Ethereum. Privacy. This is a mandate that calls for maximal privacy on default at the protocol level, and not as an add-on, not as an optional feature, but the default. And so zero knowledge proofs is a big part of that. How do you prove that agent has enough funds or that agent has a valid credential without always having to reveal that underlying data to everyone there? Security is defined a bit more broadly, but things must do what they claim to do. It specifically calls complexity itself as a risk. So simplicity, verifiability are priorities. And one of the big pieces of security is the walkaway test. Like I mentioned before, can the protocol continue functioning even if Ethereum Foundation or all of the current developers disappear tomorrow? So security, I think, is the number one feature that Ethereum for sure has. It is the most secure network of any single blockchain. And it has really high walkaway test abilities. So why does these all matter together? Each of these on its own, it's useful, but together they produce something very specific. It's infrastructure that is genuinely neutral, fully auditable, and not dependent on any single organization to keep it up and running. And that combination is very rare. Most digital infrastructure is controlled by someone, right? Think about the existing, I don't know, like if Cloudflare went down a few weeks ago and the entire internet wasn't working for a little bit. And so what does it mean to actually have like sovereign infrastructure? Ethereum is designed so that no one controls it, but what that means is the incentives are structured so that it continues to keep working that way. So maybe you have an open social network, and where you can, like right now it's open and free, but ultimately if there are people who controls it, there are economic incentives to close up that network, to no longer make it open and free. Ethereum, even if we wanted to, there is no central body that can actually make that happen. So keep those properties in mind. Everything I'm about to say about AI connects back to them. All right. So Ethereum is not just one application. It's a platform people build on. Most mature category right now for sure is finance, decentralized exchanges, lending, pool protocols, stable coins, things pegged to the US dollar. They're used very globally for payments, remittances, all of that stuff. And yeah, the largest decentralized exchanges hold billions of dollars in monthly value. Stablecoins on Ethereum are a really big growing part of global payments. So this is for sure one of the main dominant use cases on the Ethereum network. But beyond finance, we also have things like identity systems where you control your own credentials, governance structures where organizations operate through transparent programmable rules, and records and registries for credentials, intellectual properties, all of that can happen as well. And the newest category of applications that we're starting to see is Ethereum is being built on Ethereum is infrastructure for AI agents. And when you look at AI agents as economic participants, they need a very specific set of properties so that they can operate safely and credibly. Crops here is that the shorthand that I'm referring to for what we talked about earlier. And what's interesting is these are the exact properties Ethereum was designed around. So let's go through this. Identity, right? This is what we mentioned earlier about what agents can and can't do. Ethereum will, if an agent can't safely store a password or an API key and everything that you're giving this becomes training data, they'll need their own identity that doesn't depend on shared secrets. And Ethereum can give you a cryptographic identity. It doesn't have to be tied to your email or tied to your phone number. Right now, if you try to sign up for anything, a lot of it gets linked back to like a real human phone number. But agents can now have their own cryptographic identity, prove who they are with signatures and keys, and not have to worry about handling over your human personal secrets. Reputation. Again, software doesn't have LinkedIn references, courts. Agents need to track something that's public and portable. And you can do that on Ethereum. And this can be the actual foundations for what we track and build reputation on. So Ethereum, you have like agent's history of actions, payments that's doing, EIP 8004. This is the protocol underneath that's building that reputation layer for agents. Got payments that can happen at machine speed, and even something super simple like I want to buy a pizza and you have to give your credit card, maybe a debit card to be a little bit safer to the agent. What you can do with payments when they're programmable payments is you can say, you have $10 to buy a pizza. I'm giving you 10 USDC. You can only transact with this payment rail. So you can only accept it from spend it here. And this is the only money that you're given and can interact with. And so these are like rules of what it can do with your payments. And it's a lot more secure in that way. Enforceable agreements. There's no legal framework for suing an AI agent. Instead, we need agreements that enforce themselves. So smart contracts on Ethereum execute when conditions are met. No one can rewrite the terms after the fact, and no court is required to make them stick. We have neutral infrastructure. All of this has to run on rails that aren't controlled by a single company. If one platform owns that directory, the payment system, the rules, they own the economy. So Ethereum is designed as neutral infrastructure. There's no switch. Any actor can't flip or change the rules and kick an honest agent out. So when you put this all together, the big picture is Ethereum becomes the decentralized settlement and coordination backbone for machines, but specifically with humans at the center. What this actually means in practice is as AI agents become ambient, agents are embedded into apps, operating systems, services, devices. You get a lot of machine-to-machine activity that most people will never see. Agents are paying for compute, staking, escrowing, negotiating, hiring each other, logging what they've done. If that all happens on closed private rails, this ends up fully living into a handful of platforms. So what we're arguing for instead is Ethereum as that neutral layer where those machines coordinate at scale. But people ultimately are the ones who are retaining agency, ownership, and control. So Ethereum is that neutral layer. It's where agents can settle value, make commitments. It's where identity, reputation, and agreements live out in the open. And it's where the rules can be inspected and governed by humans. So when I say Ethereum for AI, really what that means is Ethereum for humans. And as we continue to build out the machine economy, we want to anchor it to infrastructure that keeps humans in the loop on the things that matter: who participates, how power is distributed, and what the rules actually are. So let's dive into what this tangibly means on Ethereum. And I'm breaking this down into two pillars. So Ethereum Foundation formally launched a dedicated AI team in this past September, and this is being led by Davide Kropis. This team is collaborating across the foundation, and it's collaborating across the privacy team, security team, ecosystem groups, and a lot of their work is organized around two pillars. The first pillar is decentralized coordination, using Ethereum as the layer where agents discover each other, build trust, transact, make binding commitments. Think of this as the infrastructure layer for the machine economy. The second layer is crops AI, building AI tools that are censorship resistant, open source, private, secure. This is work that a lot of mainstream AI companies aren't currently doing, but it's about bringing Ethereum values into the AI stack itself and also using AI to make Ethereum itself better and more secure. So let me go through what each of these mean at a high level, and then I'll show you concrete projects that are actually happening and all of that.
Yeah. Before we go deeper, do we want some stop and see if people have questions?
Yes,
Like for
100%. I had the
example, like
webinar chat open, but
yeah,
um,
it's we're typically do Q&A, but I see no questions so far, but which means probably it's a nice place to give a stop and then let people think about what are some questions. For example, I can start with some questions and we'll see if there are any people saying Q&A. So when you think about agent, there's a large language model, there are hosts somewhere, they do inferences, and they're just completely different infrastructure. And then you have blockchain, which is, as you already shown, you have proof of stake, you have smart contract, and so on, right? So far, like even after all those visions, it's hard for me to think about how those two infrastructure actually merge. For example, um, does it make sense for AI to send information through blockchain? It seems very costly because information could have been just sending a message, but then now if something goes to blockchain, it becomes very costly. And even for like infrastructure for payment, if we can use Ethereum, but then the nice thing about AI agents, we can do a lot of micropayment. And then in the sense of they're quite small, but then that doesn't make sense in the sense of if you don't have scalability for a blockchain, then I think the transaction itself can just congest the whole blockchain. And also like their AI today is pretty good at like doing API stuff and so on. Then eventually you can imagine that even without Ethereum, we can use like Stripe or other things provide API. Agent can make payment, and on the other hand, they can have all kinds of rules about like this how much this person has spent as an agent. This is how much that, right? And even more, like if you think about the whole blockchain we have, there is a smart contract, which is code as law, which whatever it says in the code, the smart contract, we have to follow that. And then the second thing becomes agent. They're essentially random. They're not like code. They just do things that we may not expect. How eventually we can reconcile those like two very different concepts. One is code is law, one is like AI agent do whatever they want. How do we even make those two completely separate infrastructure together? So I may ask a lot of questions, but I'm just trying to have a clear thing in my mind. How in any vision we bring the AI space together with blockchain space, given the fact it seems to do very different things and have different requirement for scalability and load and computation and so on. Yeah, but those are my questions. I think.
No, that is a great question. And I think one of the areas that I also want to emphasize, it's not that like Ethereum is replacing the entire infrastructure tech stack, right? There is very big trade-offs between a few places and ones where the existing tech stack can be a lot more efficient, right? Like the day-to-day actions can just have it being done cheaply versus APIs or like off-chain infrastructure. And I don't necessarily see Ethereum replacing that. More, I see it being like the long-term settlement and trust layer underneath it. So where are those pieces where trust isn't fully created? That's a little bit what happens. I do have a section later where I talk specifically about where AI and Ethereum start to merge. But yeah, I mean, I think you also mentioned a question around micro payments, right? And so, like, what does that look like at scale? And yeah, what does it look like when you have like thousands of agent actions that happen into like a single settlement, like well, and settlement transaction. And so if they can already be moving fast, cheap off chain, like why, um, yeah, like, but maybe periodically they can come in back to Ethereum. So, um, yeah, I think ultimately where Ethereum is valuable here is more in like that finality piece, that neutrality piece, those like strong guarantees so that it's not just a single platform or API or model provider that is fully like, changing the rules. So yeah, I don't see it maybe happening on every single transaction and every single thing that it's working on, but maybe like a periodic commitment as well. And so I'll share like a few examples. What the other thing to like emphasize is a lot of this agent infrastructure fairly new, right? The DAI team, September of last year, so like not even like full 6 months. EIP 8004, OpenClaw, the growth of agents this past month. What I can say is that agent infrastructure is probably one of the fastest growing areas right now in the Ethereum ecosystem. My specific role at Ethereum Foundation is developer acceleration, right? And so I look out for tools and what actually exists and why builders would talk to these tools. And we're currently doing like a hackathon right now. It's called the Synthesis. And our goal here is just to gather anyone in the Ethereum ecosystem who has tools for agents and put them in front of builders and test these things out and be like, what's working, what's not working, what breaks, when does it make sense to use blockchain rails, and when does it not? What things should be off chain? So I don't have like a super straightforward answer. I'll talk a little bit in a bit about where these things do actually merge. But yeah, I don't see it replacing the entire tech stack. It'll be pieces of it where it's relevant.
Dobson, I think Fahad also has two questions. I think he can just unmute himself and ask.
Yeah, as Sophia, so two questions, slightly different direction. One is you've sort of talked about uh, on-chain things, like you mentioned an example of paying for pizza and so on.
Yeah.
But is there also sort of as part of this vision, like a lot of say off-chain activity? Like when I was looking at ERC 8004. It looked like there was the ability for when agents register to provide like endpoints where they would interact elsewhere. And so I started to think about it through the lens of more like because there's also like a reputation aspect too, right? So in other words, like an AI agent could in principle do something for me that is not actually tracked on the chain. But then I can, in the same way in Yelp, I can say, give critical reviews, I can give critical reviews, etc. So on the one hand, if you could talk about the potential for activities off chain to play a role in this, I guess through a reputational mechanism and so on. And the second question actually is actually about more like the pizza example, which to the extent that those sorts of things happen, does that then mean that we would need merchants to actually accept payment through something that is tracked on the blockchain? Because I guess the real binding constraint, I think, to the pizza example is that the pizza places I know of don't really take any kind of crypto, right?
Yeah. Oh my gosh, I want to jump into the slides because I answered these questions like almost exactly. I'll give a sneak preview right now. I'll just answer it straightforward and then I'll jump into what this actually means. Yes, you touched exactly upon what 8004 actually does, right? It's called trustless agents as the protocol itself, but really it's a reputation system for anything that needs trust and reputation. So it doesn't necessarily have to be just an agent. You can think of things like maybe an oracle or a DeFi protocol or like these off-chain things that AI will need to interact. An API endpoint, this is a perfect example. That needs a reputation. How do I ensure that this API endpoint, maybe there's a reputation score for like end time? Like, is there like run, like, is it still working? Does that endpoint work? Is that still like up and running so that when an AI is like interacting or paying for an API endpoint, it's not like, well, this is like a dead endpoint. So how does it know that information? That is reputation, and that's like off-chain data that's not anywhere that can be and is super, super valuable if that's on 8004 as well. So yeah, you touched upon a really good point there. The pizza paying example. Okay, yeah, that sounds great in theory, but my merchant isn't accepting pizza. I'll jump into a little bit X402 here. So X402 payments and what's actually happening at the protocol level. And there's some cool tools. Actually, we have one of the sponsors, I guess, for the hackathon. One of his things, it's an X402 router. So you can pay for things like DoorDash, Fiverr, anything that maybe they don't have an X402 endpoint on their end. You pay this like router. So you say, hey, for DoorDash, and that's an X402 payment, and then they pay for that like with your payment. So they route it. In an ideal world, every payment provider would take X402, and you don't have to have like some router in between it. But if you have a server and a registry that they both, like, say everything received an X402 payment, you book your airline tickets, you book your whatever your shopping, anything, they all have like that receiver endpoint for receiving a payment. In theory, you could genuinely be paying with stablecoins across all of these actions. But you can do that now with just like one little rack, but we're not that far away from that being totally possible. Yeah, I can jump in. I actually like this is so I'm excited to these are the fun parts that I get excited to talk about, because like I feel like the first half of the presentation right now I'm just kind of setting the scene, talking about like, okay, what's happening with AI, what's happening with Ethereum, what are the different like protocol principles that embed it, like why it matters. But ultimately, like the meat and the potatoes, like the juice behind all of these things are like what Ethereum is actually being used for, right? Like where does this actually come into play? And so like I mentioned, I did break it down into these two pillars. And yeah, that first one, discovery and trust, EIP 8004, and discovery and trust for everything, not just off-chain, not just on-chain agents and like what they're doing, but off-chain API endpoints, anything that an agent will need to discover and see, like, can I trust you or can I not trust you? There is a protocol. How do we ensure that, like, the OpenAI trust thing also trusts the Claude trust thing? Like, what if they have different disputes on which one's the real neutral, like, who do I agree with, this ends up being a good, like, neutral credibility layer. Same thing, even for these API calls in general, how do we ensure that it's actually staying private and anonymous? How do we actually do these facilitating a bit between each other? So lots of this is the actual like examples of what Ethereum is currently working on around making Ethereum useful for agents. So in all of these in all of these specific areas. I kind of also broke down like our protocol roadmap, like where all these things kind of go into play. So when you have that AI coordination, that's the first part I talked about. Big part of that is identity, reputation, and X402 payments, ON infra. But we also have just like that privacy and security whole aspect that goes behind it. So maybe it's like ZK LLM credits that I'll get into in a little bit as well. Because a lot of these things, like the ones in yellow right here, are new. These are on the roadmap. It's not like live protocols. Like an attestation standard, Ethereum protocol agents, like, yeah, all these different aspects that also make Ethereum, yeah. So yeah, I just went into this with your question, but yeah, with EIP 8004, it gives agents, but like you mentioned, not just agents, gets any machine actor, any digital actor that needs reputation, identity, and reputation on a public ledger. So again, any system that we're interacting with. So I like saying API endpoints because people, I'm sure if you've ever coded or developed, you have hit an API endpoint that just doesn't work. It doesn't do what it says it's doing. And you get so frustrated. And you're like, who is responsible for maintaining this? Like, why did I do this? And, when an agent that happens, how does an agent know which ones it should be interacting with? And one specific example of like what you can do with EIP 8004, this is like protocol. Again, what I love about the Ethereum ecosystem, these are like teams on top of this, like building on Ethereum that are doing this. So this is not necessarily research that came out of the Ethereum Foundation, but this is a project that a separate group was making, and it's called Sign In with Agent. So you can think of this like the equivalent of sign in with Google or sign in with Apple, except the identity of an agent might not necessarily belong to any company. Right now, I guarantee most of the logins that we all have on average as we're logging into our Zoom, our whatever, we're probably doing some sign in with an existing identity credential that belongs to us. What does that work for agents? So here, an agent can actually mint their ERC8004 identity. It then authenticates that services to them, and they sign a message proving, hey, this is me, this is my identity, here's where I'm coming. Every API call, it's cryptographically signed. You don't need passwords, no API keys, and these requests carry its own proof. And so it's like the inverse CAPTCHA model. Instead of prove you're human, it's like prove that you're a registered agent with a verifiable identity, which is pretty cool here. We also have X402 payments that you mentioned. And so for anyone who's not familiar with X402 payments, this is just machine-to-machine payments. If you're familiar with the HTTP, okay, I see like when you hit the 404 code, right? Like you're on the HTTP protocol and you like, oh, website not found. This is like an empty thing. That 402 is a different protocol around payment required status code. And you can actually use this payment required status code as a standard way to pay for like APIs or for agents to advertise their price and prove on-chain payments. So you'll have two things in this. You have the sender and the receiver. Any agent obviously can be a sender, like you just have a wallet, a stablecoin wallet or some wallet and you're like sending cash. But what you mentioned here is like, who is that receiver? This looks really cool in theory if everyone had an X402 receiver, like DoorDash and everyone has an X402 receiver and can handle payments from all of these agents, but that's not the case right now. It's kind of the case right now. It's not a mainstream case. It is possible right now. And so we're about to see that become even more and more into reality. And it actually becomes the glue for how value begins to interact online. And it gives agents the standard way to see what something costs, maybe ahead of time, because you can see what the receiver is. You know exactly what you're sending and what you're paying because the receiver has a request on it. And you can also just prove that the payment actually sent and was settled. And so this is all happening on chain as well. Cool. Did that kind of help answer some of the questions that we had from earlier?
Yeah, to me, yes. Identity makes a lot of sense in the sense of if you have so many agents not only working for you, which you can verify, but then really they're trying to do anything on the internet, how do you verify some credentials? And that makes sense. And how do you prove that? How the whole cryptography around that is kind of very interesting. And it makes sense. It's relatively small on blockchain.
Yeah.
Can I actually just ask a follow-up question though
Yeah.
on that? But so in this case, the agent, sorry, the merchant would need to have like an X402 endpoint, right?
Yeah. Yeah.
But so can you help me like conceptually understand what's the functional advantage of that relative to, for instance, if they had just given me an EOA. Like, so for instance, I have actually paid for, say, I've actually paid for sushi in crypto before because they just had an EOA and they were willing to take it like that. So why is this even needed in that context? It seems like the merchant still has to make a conscious decision to want to kind of accept payment, right?
Yeah. Yeah. So what I think is really cool is the composability of X402. So with an EOA, right, it's like, hey, here's my wallet, like send me here. I check if something happens. The X402, incredibly simple. When you're making the request, you say exactly like what the request, like what the amount is. So you can make it like micro 0.001 and like what unlocks with that request because it's like a gateway, right? It's an actual like you go into the thing, but it's like a literal like it's like a chunk of like code that's like it's like a wrapper and then it's like a gateway and it like unlocks something when you do that with a specific thing. The main area that we're seeing it, I'd say like maybe if you're like paying someone like in the pizza example, I actually don't know if that would be the most useful thing for X402. I could see just like an EOA is like a perfect example. Pizza is $12. I got $12 done. Like we don't really need to do an X402 version in that way. But when it comes to anything around like micro payments, unlocking API, and we're like paying for like ongoing API as you like as like you want to pay like a cent every time you're like calling a model, right? Like that would be just such an annoying user flow as like a human to be like, okay, like accept payment, do like a cent, all that stuff. An agent, super simple. Like you have that stuff and like you can like do like genuine pay per use. Um, I was in a hackathon team like a few weeks ago with a few other just like friends, just because I like to do hackathons on the side. Make sure my skills are still sharp. If I'm selling, talking about this, I need to make sure I'm doing it too. What my team built was research papers that get unlocked based off of your like the email domain that you're requesting it from. So if you're requesting it from like A16Z, like an email domain that's like A16Z.com, it'll be like, okay, we tell that based on your email domain, you probably have more money. And so therefore I'm going to charge you like the full price. And then if it's like a stanford.edu, oh, you're a student, you're in academia, I'll charge you a cheaper price. And so you can like kind of make these rules embedded, and it's really simple to actual code that you do that on. You can like write all these rules about what you want to do around payments that's natively on the protocol level itself, which is pretty cool. So yeah, I think it's like when you have like these dynamic pricing, when you have microtransactions, when it's these things for unlocking and you need a lot more customization or flexibility around how payments flow, that's where X42 can be super valuable.
That makes a lot of sense. Can I just, if I
Yeah,
understand correctly, I think what you're saying is first, it's very standardized. Everyone can use
yeah,
the same similar format. Second thing is that apart from standardization, they also have composability come from the and programmabilities. And those are very important. And it may not be the only answer, but whoever have the standard that is have all three feature and what it does can have network effect. Is that what you trying to get there? Something like that. I don't know.
exactly. Exactly. 100%. Um, cool. I'll jump into just some of the other stuff because there's a few other examples that would be really fun to chat about and what's actually happening. I also want to give enough time to talk about the future things that are currently being worked on. Those are the areas that I think are so cool and I'm really, really excited about. But yeah, I mean, from a high level, we got the like building AI that embodies Ethereum's design principles. And so, like, some of the specific ways that this is actually happening is the Ethereum Foundation is doing a lot of active research on AI powered protocol security. So this means AI agents that are auditing smart contracts, parsing evolving specifications. So lots of things around there. The ZK like LLM credits. This is a joint effort with the privacy security on Ethereum team. And this is, yeah, the idea is you can use like zero knowledge proofs applied to language model interactions. So an AI can process private data and return a useful result. And that proof guarantees the raw data was never exposed to anyone and not even the model operator. And so this is like really like privacy embedded at every layer. Um, and and yeah, and so those are some of the other like aspects that are happening as well. But again, yeah, wanted to emphasize that like the crops AI, this is like a big piece and area of our design principles, but it is still a little bit of a blank space. A lot of them right now are in research and theory, and less applied in practice. But we find that that's typically how Ethereum Foundation kind of starts and kicks off a lot of these research and theory pieces, and it's the builders on top of the network that use that into applications and use cases that make more sense. Um, the Another thing I wanted to just like zoom out and talk a little bit about. This is more like Vitalik's standpoint on where he sees AI like evolving into and where Ethereum's role is. He says like it kind of coins the terms like sanctuary technology. So it's a lot more of these like open source tools. They let people coordinate, manage resources without depending on single actors. And like think about other tools that are kind of in this sanctuary technology field. This would be something like Signal for encrypted messaging, or like an open source AI model that runs locally. I think like local hardware could be a really cool like area. I don't obviously like I mean Ethereum is not doing anything right now specifically in that, but like open hardware projects would be a really interesting like play and like potential that we'd want to see more things being built into. Um, But ultimately, you can think of like Ethereum as this like shared digital space where that's creating persistency in programmable objects. Um, and then again, big thing I just keep emphasizing here is like AI is the engine, humans are the steering wheel. And so these are specific design principles for how AI and governance and human governance should interact. And this is the next example I'm really excited to talk about as well. But it's like, how do we make the rules of the game simple, open, and stable? And you let AI agents compete for those rules. So maybe you put like humans provide their input, things like their goals, their values, like what they want to see happens. And AI handles the volume and the coordination. So you can think of this even like as a country, right? If you're a whole country, you guys are like hundreds of millions or whatever of people. How do you take the important pieces of the human aspect, like what our values are and what we want to see money being done with and what we want to see policy decisions doing, but then allow AI to kind of like synthesize and handle this. Uh, so yeah, same logic that makes markets effective, like Ethereum can make that happen. So one of the examples that is actually we're actually doing and prototyping this in real life is deep funding. So this is a pilot that's happening through the Ethereum Foundation, and it's actually using AI agents to allocate like over like $1 million in public goods funding. So right now there is about like 4,300 code repositories that are connected to dependencies in relationships to the Ethereum ecosystem. And if you look back like a year or two ago, and I don't want to misspeak since I don't have a full knowledge about how this worked, but a lot of these open source repositories, a lot of the dependencies that in the public goods for the Ethereum network were funded through grants, and these grants get funded through a committee. And it would be a huge bottleneck because sometimes it's like humans who have biases, maybe they've heard of certain projects, maybe they know people at certain projects. You can do certain things like looking at like GitHub repos, but it really quickly it gets hard to tell like which things were actually impactful to, especially as a public good, right? The definition of this is like, okay, it has to be a public, like us as a mass consensus agree that this is a public good and this is like really valuable for us. And sometimes you have two teams that do really similar things. How do you determine like which one should get the grant and which shouldn't? And is it fair that it's all being decided by like a grant committee of three people, right? Like, is that really the design principles and fairness of us of humans? And so deep funding looks to replace that. Essentially, you have like it's like distilled human judgment. You have a big jury of people, of humans, like 50 to 70 people, and they evaluate a small random sample of contributions with really high quality. So maybe we're like reviewing like 10 of these open source repositories. Anyone can submit an AI model that proposes evaluations of that entire set. And that AI model that best aligns with the jury's answer can determine the final allocations. So it's this is a really cool way that you're seeing like humans are providing like this like calibration. They're actually calibrating like what they want to see in their values, and then AI scales that. So it's like human values scaled by AI. And yeah, it's really cool. We're prototyping this with like an actual economic machine, and you could see this happening. Maybe like I would love to see a nation state embed deep funding to be like, all right, like how should we divide up public goods for our nation state, and things like that too. That would be a really cool experiment to see piloted.
Good question. Just
Yeah.
to understand clearly, so like you have some experts who give votes or scores for all those projects, and you
Yeah.
have a certain rules like dependency and so on. And then you have additional group of people who are coding AI agents and meet into the project. And eventually the criteria of choosing whatever or the choosing AI agent is actually who actually matches better score with the expert.
Yeah.
Is that the okay?
Exactly. So there are multiple agents that are like the voters that decide
Mhm.
like I'm gonna say like I'm the shark agent and I care about like technical complexity and making sure that like this is like innovative technology, like not anyone can do this versus I'm the like um whatever agent who cares that about like I care about like mass people, like every person is using this, as it's just widely used, even if it's not that valuable. Like I care about like a lot of people. So maybe people have different values for like what genuinely should get funding and what should get paid for. So AI doesn't try to like take those values and make a decision on what those values should be. Rather, there's all these different agents, and then humans will say, here are my actual values, and it gets mapped to an agent that aligns closest with those values and would vote on average like consistently with you, and that's the one that scales that input and actually does some of the allocation and voting. So it's like, so yeah, so because
Yeah,
you don't want to
I
make
think
an AI decide what.
it's a hard question because yeah, eventually you have to. It's like there's a lot of meta learning, which is like the agent has to learn from the referee all the time, and you also have to have a knowledge base or memory that keep track of how not only they match things statistically temporarily, we want to make sure they truly memorize how people make decisions, make sure they follow that. I think that's just a very exciting, but very, very hard to be robust thing. And it's extremely exciting. And also like people have to think about what should be done by code, right? What do you have on the graph here is like you have some hard gates or constraint on this has to be sum up smaller than one, and some has to be done by LLMs. And yeah, that's super interesting.
No,
I
I
think there's a
totally agree.
question.
Oh yeah, yeah.
I think there's a question in the Q&A. Yeah.
Oh, it's in the Q&A. Should I open it up? Now let's see. Yeah, what is the mechanism that stops AI agents being set up to manipulate the allocation process? In this deep funding version, it's not fully autonomous. So you have humans ultimately who are involved in the flow of like reviewing the agents and like how they're actually voting, and then humans at the end can say like, okay, like this does align with what I'm doing. Again, it's like 4,300 code repositories, so it's like really annoying to look at like as a human, but like not impossible. You could still like get back your answer and then review. We're doing like a micro version of this for the hackathon we're actually running as well, where the judges like we have like 1,000 projects, and the judges have to decide who are the winners of these projects. And we're actually getting every judge to like do a deep funding synthesis vote where they say like, okay, out of these projects, here's what I like and why. And then it does like, okay, based on that, here's a model that would likely vote with your biases and like what you're looking for. Um, but yeah, I think the big piece is I would say like human augment, like it's a helper. Like it's not supposed to fully replace the decision maker, but rather it can help them scale it. So yeah, I think in general, I'm really excited when this gets applied to treasury management. Like, hey, how do we all agree that we should spend a treasury together, right? And so I would love a big problem with this is literally countries. Who makes decisions over how countries spend their treasury, and how do you decide like how money should go to support the most public goods for the most people, and what's actually impactful? Really interesting questions that you kind of get into. A little bit of just like what's coming. Um, yeah, like I mentioned, ERC 8004 validation registry. This would be like everything happening on a trusted execution based verification. And so yeah, this is an exciting area. We got expanded private payment infrastructure. So like imagine like X42, all these payments that you're doing, but you can actually ensure that these things are happening securely and privately. Automated negotiations between agents, smart contracts, more integration with AI frameworks, enterprise tools, and all of that fun stuff. Deeper university research partnerships. I think the academia team literally has like research, like PhD grant subsidies and things like that as well. So definitely check that out if you're interested in doing deep research in any of these areas. There are actual grants for PhD students to work on this. Yeah, this is pretty much most of what sharing here, but yeah, again, it's really just about this public infrastructure and ownership that makes Ethereum this coordination layer no one controls, but designed around properties of crops. And as agents become the fastest new growing category of economic actors, they'll really need some type of infrastructure that allows humans to continue to make rules and continue to have ownership and rights about like how all of these things are interacting. So it's not necessarily that, yeah, this infrastructure that AI agents transact on will be shaping how our economy works. And so the question is, what should that infrastructure be? How should it be designed? How should it be controlled? And yeah, these are fun economic theory coordination people questions, and it's actively being shaped right now. I don't want to say here like I have all the answers and this is exactly what's going to happen. I really want this to be more like a call for action of like, hey, it's being shaped actively by whoever shows up. It might happen on this global coordination layer. It might happen in some like big closed AI lab or some protocol there. I don't know. Or some country that decides some legislation and policy that decides what is private, what's not private, and it's not actually embedded at the protocol level. It's an afterthought. So, yeah, if you want to continue getting more involved, definitely I have these like resources linked, just more around 8004, but AI, Ethereum Foundation, you can see the whole roadmap for what's happening, the privacy, scaling, and security enterprise on Ethereum is a great resource to look at too, pse.dev. So yeah, definitely encourage you to continue going deeper. You can also just message me if you want to just chat about any of these fun things. Here's my email, and I'm pretty active on Twitter as well. But yeah, I love talking about these things. These are open landscape, really like can't emphasize enough, super, super early days. So yeah, it's been very much the goal is to collaborate all together and to start building this all together.
Thank you so much, Sophia. Let me see if there's more questions in the chat. If you have more questions for Sophia, I think that's the time. If not, thank you so much for putting us the frontier of decisions where things are merged. And I think it's still open question for both the industry and academia to think about where AI and blockchain can really merge. And you point out all different pathways and possibility or even potential collaborations that can happen. And we really thank you so much. And,
Yeah.
and
Likewise.
if
No,
there's
thank you as well so much. And yeah, again, it's really at the forefront of everything. And maybe the next time I give this presentation, it'll have a bunch of examples of like the cool stuff you're working on and like the cool research other folks are coming out with. So yeah, it's really just like this collaborative landscape. And so really excited to talk today. And one of the big emphases of Ethereum Foundation is working really closely with universities and research that universities are doing. So yeah, definitely feel free to, if you're in that realm doing things in this area, feel free to email me. The best way to get in contact, and would love to learn more about what your university is working on and how we can support as well.
Thank you so much. That's amazing. Thank you for all the support and thank you for your time. And hopefully everyone have a great coming weekend.